Now let's look at our second example that we have. Now, this example is a little bit more challenging because it's kind of a backwards problem, and I'll talk about that as we go through it. The text says, Jeremy just received a 150-gram shipment of oxygen-15 from the cyclotron across the street from his radiology lab. It took the cyclotron workers 12 minutes to pack up the oxygen-15 doses and deliver them. How much oxygen-15 was there before the long trip across the street? And what we want to do is once again round our answers to the thousands place. So before we get started on the actual problem, let's get some important information down. Now this has got some different important information, so we want to make sure that we're clear on that. First thing I notice is that they give us the amounts, and they give us the final amount to begin with. It says Jeremy received a 150-gram shipment. So this is what he gets. So this is going to be our amount at the end, at our time t. So that's going to be 150 grams. Okay, now the initial amount is actually the thing that we're solving for. So that is not something that I know right off the bat. So I'm going to give it a question mark. That's what makes it a backwards problem. Another fact that we have is we know that it's oxygen-15. And if you pay close attention to oxygen-15 on, once again, our focus slide, you'll notice that the half-life for oxygen-15 is just a mere 2 minutes. Now that's a pretty small half-life. There are some half-lives that are even smaller than that are just seconds or even parts of seconds, but there are also a lot of half-lives that are like 80 years or 150 years. Okay, so that one's actually pretty small. The other thing that they tell us, and this is an interesting fact, is they give us the time. They said that it takes 12 minutes to pack it up across the street. Now, I don't know how long it takes me to cross the street, so I think that's kind of funny. So there's your time right there. What we're going to do once again is we're going to take all this information and plug it into that formula that I showed you a couple videos ago. So I'm just going to take every piece that I can and plug it in, and everything that is left over is going to be something that we're going to need to solve for. So the first thing, A of t, is something that we actually know. In the last lesson, we didn't know that, but this one we do. So it's going to be 150. A naught, or your initial value, is not what we know. We do not know what that is, so we're just going to leave that as a variable. And yes, that little 0 right there is part of the variable, so make sure you include it. E is a constant once again, so we're going to leave that alone. And our big fat exponent, by far the most challenging part of the whole equation. So let's get those pieces in. Natural log of 2 is negative, and it's a constant as well. T 1/2 is our half-life. With oxygen-15, so that means it's 2 minutes. At our time is going to be 12 minutes. Now this is cool about this problem is the fact that they gave us both our half-life and our time in minutes. They're consistent, so we don't have to convert anything like the last one. So we just pop our 12 in. Once again, we're going to start by working with the exponent first. So I want to do my division and then my multiplication, and then I'll move down to these guys down over here. So up to here, I have not changed a single thing. This is where I'm going to start my calculations. So division first, multiplication second. You do both steps, you're going to end up with negative 4.159. That'll be your value. And then what we're going to do is we're going to do our exponents. It's going to be e raised to the power of that guy. Okay. Round it to the thousandths, I get 0.016. Now this is a little bit of a different situation. What we have to do is we now have to actually perform a little bit of algebra in order to get the A naught, or our initial value, alone. So this 0.016 actually needs to be moved over to the other side. And since it's A naught times 0.016, what we're going to do is we're going to do the opposite of that. We're going to divide on both sides. And once again, this is the one part that makes this problem a little bit more challenging than the last one, because you have to rearrange some of your pieces. So we're going to do this piece of division right here, and this is going to give us our final answer. So, 12 minutes ago, when our isotope was over at the cyclotron, they had made 9,601.122 grams of oxygen-15. 12 minutes journey to get packed up and moved across the street, it had already decreased down to 150 grams of oxygen 15. And that is the power of the half-life.